Hello students, welcome to the class. So today we are going to continue with the next questions of our that is motion in a straight line chapter. So already we have completed 10 questions. So let us continue the next question. Our next question is the displacement of the particle is given by y is equal to a plus bt plus ct square minus d t raised to 4. So equation what they have given, the displacement equation is given as a plus bt plus ct square minus dt raised to 4 is the given equation. Here we need to calculate the initial velocity and acceleration respectively. So already we know the rate of change of displacement is called as what? Velocity. And the rate of change of velocity is called as what? Acceleration. So first you need to differentiate once to calculate velocity. Again you need to differentiate to calculate acceleration. How we can do this one? That is, so velocity v is equal to, I can write it as dv divided by dt, that is equal to d divided by dt of y value is a plus bt plus ct square minus dt raised to 4 is equal to, as we know with respect to t we are differentiating, so the differentiation of a is 0 plus differentiation of b into t, it is b plus differentiation of ct square, it is 2ct minus differentiation of d raised to 4 is 4d raised to cube. Okay, here they have asked you initial velocity. So when it is mentioned as initial velocity, we take it as t is equal to 0. We take it as t is equal to 0. Or let us integrate. First I'll integrate this or differentiate this equation also, that is acceleration is equal to d square y divided by dt square. Now what is the equation? That is integration of this above equation. So differentiation of above equation, differentiation of b, it is 0 plus differentiation of 2ct, it is 2c minus differentiation of 4d cube. 4d t cube is nothing but 4 3s are 4 3s, it is 12d square, 12d square, right? So this is what your equation of acceleration. Here we can substitute in this, we can name it as equation 1 and this we can name it as equation 2. So this equation I can name it as equation 2. Okay, so after naming this as equation 1 and 2, here if I take t is equal to 0, if I take t is equal to 0 in equation 1, if I take t is equal to 0 in equation 1, it becomes what it becomes. See here, that is t is equal to 0 means second and third term will get 0. Therefore, we will get b is equal to initial velocity. Therefore, I'll take it as u. So this is b value. Next, now if I substitute t is equal to 0 in equation 2, if I substitute t is equal to 0 in equation 2, then here it becomes acceleration is equal to 2c. So in the question, they have asked you to calculate the initial velocity and acceleration. You can see here the initial velocity you are getting it as b, and you are getting the final acceleration as what? 2c. So you can see where it is given b and 2c is the answer. That is option C is the correct option. Option C is the correct option here. Is it clear? Okay. The next question. Next question is the relation between time t and distance x is t t is equal to alpha tx square plus bx, where alpha and beta are constant. The retardation you need to calculate here. Okay, so how to calculate retardation? As we know that retardation is nothing but what? Negative acceleration. Retardation is nothing but it is negative acceleration, correct? So therefore, what we can do here, we can use the equation of retardation. That is, see here, the solution is, here we know that if I take this equation as, they have given t is equal to equation. Therefore, if I differentiate tx divided by dt is equal to, so here t is equal to, it is given, therefore it becomes dt divided by dx is equal to, dt divided by dx is equal to 2 alpha into x plus beta. So what I did, I have differentiated that equation with respect to x, right? Next step. So next here, what we can do, next is, this is what, this is dt by dx is equal to, now what is velocity? Velocity is given by, v is equal to dx divided by dt, that is equal to, so what is the value of dx by dt? So dx by dt is what? 2 alpha beta x plus beta. This differentiation of this term can be written as 1 divided by 2 x into alpha plus beta, that is your v is equal to. So here it is dt by dx. Actually velocity is what? It is rate of change of displacement. So I need to take it as reciprocal. Therefore v is equal to what? 1 divided by 2x into alpha plus beta. Therefore acceleration a is equal to, it is dv divided by dt, that is equal to, I can rearrange the term and I can write it as dv by dx into dx by dt. See here what I can do now. This is dv by dx into dx by dt. So we know already dx by dt value, you can see in the given equation. But what is dv by dx? So dv by dx can be written as, that is dx by dt. So here this equation I'll name it as equation 1. So dx by dt is nothing but what? It is v. Therefore I can write it as dv by dx into v, that is equal to, so what is dv value? It is 1 divided by 2x alpha plus beta. Therefore here it is dv by v, I'll keep as it is. Now the differentiation of 1 divided by 2x alpha plus beta. The differentiation of this is given by 0 minus 2 alpha divided by 2 alpha x plus beta square. Therefore, this is nothing but minus 2 alpha into v. 1 divided by 2 alpha x plus beta is nothing but what? It is v. But here it is given as v square. Therefore, it becomes v square. Therefore, this is nothing but 2 alpha into v square is nothing but 2 alpha v cube. I'll explain this sum once again, because see here, see the question is what? The relation between time t and distance x is t is equal to alpha x square plus beta x, where alpha and beta are constant. The retardation is given by. So how to calculate the retardation? See this step. That is, this is equation is given in terms of t. Therefore, I'll differentiate this with respect to x. Therefore, it becomes ddt by dx is equal to 2 alpha into x plus beta. Now, here velocity we need that is acceleration. To calculate acceleration, we need velocity. So what I did, velocity is equal to dx by dt, which is equal to 1 divided by 2 alpha x plus beta. Why? Because in the above step, it is dt by dx. Dx by dt is nothing but what? Reciprocal of that. This you can name it as equation 1. Next, acceleration is equal to, it is dv by dt. Therefore, dv by dt can be written as dv by dx into dx by dt, which is equal to dv divided by dx into v. Why? Because from the equation 1, you can see here, dx by dt is nothing but what? V. Therefore, dv by dx into v is equal to, this v I'll keep as it is. Next, dv by dx, v is equal to what? 1 upon 2x alpha plus beta. I need to differentiate the equation. So after differentiation, I'll get it as 0 minus 2 alpha divided by 2 alpha x plus beta whole square. Now this v, it is kept as it is. Minus 2 alpha is also kept as it is. What is 1 divided by 2 alpha x plus beta? That is nothing but it is v. Therefore, it is becoming v square. That is nothing but v square into v is v cube. So 2 alpha v cube is the answer. That is option A is the correct option here. Okay. So here, how to rearrange the terms, how to do this, that is important. Okay, main is rearrangement. Nothing, it is nothing but retardation, acceleration only we are calculating. As the answer you are getting in terms of minus means what it indicates? It is the retardation. It is the retardation. Okay. Then our next question. If displacement of a particle is directly proportional to the square of time, if displacement is directly proportional to the square of time, then particle is moving with, see, here, when we say that the particle, here it is given that it is directly proportional to square of the time. What I need to write here? To write it as the displacement of the particle is directly proportional to the square of the time, then particle is moving with, here x is proportional to t square, which is given in the question. I can write it as, this implies x is equal to k into t square, where k is what? Constant, where k is constant here, right? Therefore, v is equal to, I can write it as dx divided by dt, that is equal to dx by dt. So d divided by dt into x value is what it is? K t square. This is equal to, so k t square differentiation is 2 into k into t. Is it right? This is what? Velocity. Now acceleration is given by what? dv by dt. Therefore, dv by dt, what I can write? This is d by dt of 2k into t. This is equal to, so this 2k is the answer. You can see here acceleration, you are getting it as 2k, velocity you are getting it as 2kt. It is clear that velocity is time dependent. You can see here your velocity is dependent on what? It is time, and acceleration is not depending on time. 2 is constant, k is constant. So therefore we say that acceleration is not depending on time and velocity is depending on time. So we can say that the particle is moving with uniform acceleration. So what all options they have given? See, uniform acceleration, variable acceleration, uniform velocity, acceleration, but uniform velocity. See, variable acceleration, it is not true because acceleration is equal to, we are getting 2 into k. 2 is constant, k is constant. Therefore, acceleration is not varying. Uniform velocity is not possible. Why? Because velocity is equal to 2 into k into t we are getting. Your velocity is changing with respect to time. Therefore, that is also not correct answer. Fourth option is what? Variable acceleration but uniform velocity. Variable acceleration but uniform velocity. So, variable acceleration is not possible as acceleration is not depending on time. Therefore, the correct option is option A. Option A is the correct option. Is it clear? Then next question. Next question is, a particle is moving eastwards with a velocity of 5 meter per second. With a velocity of 5 meter per second. In 10 seconds, the velocity changes to 5 meter per second northwards. The average acceleration in this time is, so a particle moving eastward, it is moving eastward with velocity of 5 meter per second. In 10 seconds, the velocity changes to 5 meter per second northwards. Okay, so after 10 seconds, the velocity is changing as well as the direction is also changing. The average acceleration you need to calculate. So to calculate average acceleration, you require velocity first. Time interval it is given, it is 10, right? So let us draw the diagram. That is, here you can consider the direction as this is east, north, west, and here it is south. Okay, so first it is moving eastwards. First it is moving eastwards with 5 meter per second velocity. Then it is moving north. Then it is moving northwards with a speed of, or with a velocity of 5 meter per second. We need to calculate the average acceleration that will be along this direction. Okay, so let us calculate this here. That is, change in velocity is equal to v2 minus v1. As it is a vector quantity, I need to denote it with vector symbol. Delta v is equal to v2 minus v1. That is, delta v is equal to under root of v1 square plus v2 square minus 2v1 v2 cos of 90 degree. Because you can see in the figure, the v1 v2 are perpendicular to each other. Therefore, we can take it as 90 degree. Theta is equal to 90 degree. v1 square plus v2 square minus 2v1 into v2 cos 90 degree. Now this is equal to under root of, this is equal to under root of phi square plus phi square, because cos 90 is how much? It is 0. Therefore this entire term becomes 0. v1 v2 values are same, that is phi square plus phi square is equal to 25. So root of 25 is equal to phi root 2. Phi root 2 is the velocity. Then next, average acceleration is equal to, so average acceleration is equal to, we take it as delta v divided by delta t. That is equal to, delta v value is phi root 2 divided by delta t value is 10. So phi 1s are, phi 2s are. This can be written as 1 divided by root 2 meter per second square. 1 divided by root 2 meter per second square. Okay, next. So as you can see here, option A is 0, option B is 1 by root 2 meter per second square towards northwest. Option C is 1 by root 2 meter per second square towards northeast. Then 1 by 2 meter per second square towards northwest. Okay, option A is wrong. Option D is also not correct, because we are getting acceleration as what? 1 by root 2. Option B and C are containing 1 by root 2. Then which is the correct option here? So to understand which is the correct answer, you can see the figure here. If you see the figure, you are seeing that it is towards northwest. From the figure, you can understand that it is towards the northwest. That is option C is the correct option. Option C is the correct option here. 1 by root 2 meter per second square towards northwest. Option C is the correct option. Right, students? So let us continue in the next question. Okay, next question. So question is, the displacement time graph for two particles A and B are straight lines. So displacement of the particle is a straight line which is inclined at of 30 degree and 60 degree, which is inclined at 30 degree and 60 degree. With the time axis, the ratio of velocities of VA is to VB is, we need to calculate the velocity ratios. So here the angles are given. How to do this? See here. That is, we have V is equal to tan theta. V is equal to tan theta. From the displacement time graph, we can write V is equal to tan theta, where VA divided by VB is equal to, VA divided by VB is equal to tan of 30 degree divided by tan of 60 degree. Tan 30 divided by tan 60. So which is equal to 1 divided by root 3, because tan 30 is 1 by root 3 divided by tan 60 is how much? It is root 3. That is nothing but what? 1 by root 3 into root 3. Correct. So the final answer you are getting it as, it is 1 divided by 3. So the correct option is option B. 1:3 is the correct option. So simple question, but you need to remember this formula, that is V is equal to tan theta. The ratio of velocities are 1:3. That is option D is the correct option here. Let us see the next question. From the following displacement time graph, find out the velocity of a moving body. We need to find out the velocity of a moving body. See here, in the first instant, we need to apply. The time is along y-axis, the displacement is along x-axis. It is making an angle 30 degree. So again, velocity can be calculated by using our previous equation, that is velocity is equal to tan theta. But here from the graph, the solution will change little. First, in the first instant, by applying, in the first instant, we can apply the formula V is equal to tan theta, that is equal to tan of 30 degree, that is equal to tan of 30 degree, which is equal to 1 divided by root 3 meter per second. But here what happens, why we are not using this concept? Because here this is measured when the angle is measured with the time axis, when the angle is measured with the time axis. But here in the figure you can see the angle is measured with the displacement axis. It is measured with the displacement axis. Therefore we take that, so angle from time axis, angle from time axis, here you can see. So this is the time axis. So what is this angle? It is 90 degree. Therefore this is equal to 90 degree minus 30 degree. 90 degree minus 30 degree, it is what? 60 degree. Therefore V is equal to how much we are getting? Tan 60, that is equal to root 3. Option C is the correct option. See, by reading the question, what you will feel, we can apply the velocity is equal to tan theta formula here. But when you apply velocity is equal to tan theta formula, you make sure that the graph is between displacement and time, where time is along x-axis and displacement is along y-axis. But here the case is the displacement, they have taken it along x-axis and time is along y-axis. Therefore it is V is equal to tan theta, that is tan 30 degree. So tan 30 degree is how much? It is 1 divided by root 3 meter per second. But here this is not true, or this is not correct. Why? Because here it is making angle with the displacement axis. Therefore we are changing that angle from t-axis as 90 minus 30 degree, that is 60 degree. Now we can go for V is equal to tan 60 degree, that is root 3. So to make you confused, they have given both the options. So you need to see the figure properly first. Okay, then next, let us see the next question. The diagram shows the displacement time graph for a particle moving in a straight line. The average velocity for the interval t is equal to 0, t is equal to 5 is. So here the diagram shows the displacement time graph for a particle which is moving in a straight line. We need to calculate the average velocity for the time interval of t is equal to 0 to t is equal to 5 seconds. So here the figure is little missing. 1 second. Okay, so here it is there. See, the figure is given in the diagram. Average velocity from the diagram we need to calculate. That is, average velocity is equal to, it is total displacement divided by total time taken. It is total displacement divided by total time taken. This is equal to what we can take. This is equal to, we can take it as 20 plus into bracket minus 20 plus into bracket minus 10 divided by total time. Total time, you can see in the figure, the total time is 5. This is equal to, see why I have taken it as total distance as displacement as 20 plus minus 20 plus into bracket minus 10. See here, from 0 the displacement is plus 20 first. So here it is plus 20. Then you can see it is coming down to this point. It is coming down to this point, that is minus 20. Then again it is coming down and down, that is minus 10. So that is what total displacement is, 20 plus into bracket minus 20 plus into bracket minus 10 whole divided by 5. That is time. Therefore, we can write here as it is equal to minus 2 meter per second. As it is velocity, the unit is meter per second. Why? Because 20 minus 20 is 0. Minus 10. So 5 ones are 5 twos are, that is becoming minus 2 meter per second. Therefore, the correct option is option C. Option C is the correct option here. Okay. Next question. For the velocity time graph, shown in the figure. So here you can see the figure which is given below, that is the distance covered by the body in last 2 seconds of its motion is what fraction of total distance covered by it in all the 7 seconds. So here we need to calculate, that is the distance covered by the body. See here, for the velocity time graph, it is shown in figure given below. The distance covered by the body in last 2 seconds you need to calculate, that is between 3 to 5 of its motion is what fraction of the total distance covered by it in all the 7 seconds. How to do this one? See here, students, that is distance covered. Here we can write it as distance covered in total 7 seconds. Distance covered in total 7 seconds is equal to area of trapezium. You can see the figure. It is looking like a trapezium of A, B, C, D. This is equal to 1 divided by 2 into, what is the formula for the area of trapezium? It is half sum of the parallel side. Sum of the parallel side, it is taken as 2 plus 6, okay, into, it is 10. Here you can see this is what? This is the H value, that is 10. And here it is the sum of the parallel side, it is 2 plus 6. Therefore, so if I simplify this, I will get it as 8 by 2. 8 by 2 is 4. 4 into 10 is 40. 4 into 10 is 40 meter is what? Distance covered by. What we need to calculate? We need to calculate distance covered in all the 7 seconds we need to calculate. So this is what? Distance covered in total 7 seconds. Distance covered in last 2 seconds. So distance covered in last 2 seconds is how much? See here, it is given by distance covered in last 2 seconds is equal to area of, it is equal to area of triangle CQD. CQD is equal to 1 by 2 length into breadth, that is 2 into, that is 2 into, it is 10. This is equal to, so 2 will get cancelled, that is 10 meter. Now here we can take the fraction, that is the ratio. So it is 10 divided by, so required fraction. Therefore, the required fraction is equal to 10 divided by, it is equal to 10 divided by 40. So 0 will get cancelled, that is 1 divided by 4. So what is 1 divided by 4? Here the option is option B is the correct option. Option B is the correct option. See, once again I'll repeat. For the velocity time graph which is shown in figure below, the distance covered by the body in last 2 seconds of its motion is what fraction? Okay, to the distance covered in all the 7 seconds. So separately you need to calculate the distance in last 2 and 7 seconds. So to calculate last 2 seconds, we can use the help of area of triangle. Triangle we can say CQD, and trapezium we can take ABCD. Okay. So this is how we can write. The answer is 1 by 4. That is option B is the correct option. Let us see the next question. Next question. The velocity time graph of a body moving in a straight line is shown in figure. The displacement and distance traveled by the body in 6 seconds are respectively. So here you can see that is area of rectangle we can use, that is ABCO, then DCEF, F, G, H, I. So 3 rectangles we can use, then we can calculate the displacement and distance traveled. Okay. So in that way, we need to think the problems. When the figures are given, so many people, what they will do when the figures are there, they will skip the question. So actually the figure questions will be always, it is easier than the other questions. Okay. So here the area of rectangle ABC O is equal to, it is 4 into 2. That is length into breadth. So length is 4, breadth is 2. Therefore 4 into 2, it is equal to 8 meter. Next is area of rectangle CDEF is equal to, CDF is equal to 2 into, can I write it as -2? You can see here in the figure, the graph is below the x-axis. Therefore, it is -2. This is nothing but how much it is? 4 meter. Now, similarly, area of FGHI is equal to 2 into 2, that is equal to 4 meter. That is equal to 4 meters. So, students, here displacement is given by, here displacement is given by is equal to sum of area of the sides, that is 8 plus into bracket -4 plus 4. That is nothing but +4 -4 will get cancelled. Therefore, you will get it as 8 meter. You can see in the option A, B and D, 8 meters are there. That is displacement. But we need distance. We need distance. So distance is equal to sum of area without the sign. Why? Because here displacement and distance, what is the difference? Here distance is only magnitude, displacement is what it is with the symbol, with the direction, right? Therefore we can take it like this. Right? So therefore distance is equal to how we can write it is 8 plus 4 plus 4, that is equal to 16 meter. That is equal to 16 meter. 8 plus 8, that is 16 meters. So the correct option is, first option is 8 meter 16 meter, second option is 16 meter 8 meter. See the way how they are will confuse. See the question, the displacement and distance they have asked. Displacement is 8 and distance is 16. Therefore option A is the correct option. Option A is the correct option. Let us see the next question. The next question is, a body A moves with a uniform acceleration A and 0 acceleration and in initial velocity. Another body B starts from the same point, moves in the same direction with a constant velocity V. See, body A moves with acceleration of A and 0 initial velocity. And the body B starts the same point and moves in the same direction with a constant velocity. The two bodies meet after a time t. The value of t we need to calculate. The value of t we need to calculate here. So here, how we can do this? That is, let they meet after time t. Let them meet after time t. Distance covered by A is equal to, distance covered by A is equal to half at square. Why? Because distance covered by A is nothing but the formula is S is equal to ut plus half at square. As they have said, A body is at rest. Therefore, its initial velocity becomes what? Its initial velocity becomes 0. Therefore, the equation becomes half at square. Then next for B body. Therefore, for B body, the equation I will take it as V into T. Okay. Now, as they will meet at one point, therefore we can say that A is equal to B. Therefore, I can write it as half at square. We can write it as, here I'll write half at square is equal to V into T. Therefore, T is equal to 2V divided by A. Is it right? So, T is equal to, T will get cancelled. Therefore, T is equal to 2V into 2V divided by A. T is equal to 2V divided by A. That is option A is the correct option here. Option A is the correct option. 2V divided by A. Let us see the next question. Next question is, a student is standing at a distance of 50 meter. So the distance is given 50 meter from the bus. As soon as the bus starts its motion with an acceleration of 1 meter per second square. So acceleration is there, distance covered is there. The student starts running towards the bus with a velocity of u, assuming the motion to be along a straight road, the minimum value of u, so that the student is able to catch the bus. So here we need to calculate the value of initial velocity, means how much velocity he should give to himself to reach the bus. So the solution is, see what all they have given. The distance covered is equal to, so he will catch the bus in the sense his final velocity will be 0. Therefore, I can write the equation as T is equal to ut. The distance covered is equal to, okay, so distance traveled is equal to, by the bus, wait, that is distance covered by the student, distance covered by the student is equal to ut. Distance covered by the student is equal to u into t. Similarly, distance traveled by bus is equal to, distance traveled by bus is equal to half at square. Therefore, distance covered by student is ut is equal to, this is 50 plus half at square. 50 plus half at square, that is equal to 50 into, acceleration is given 1, therefore it is becoming 50 plus 1 by 2 t square, that is nothing but t square divided by 2. T square divided by 2. Therefore, I can simplify and I can write it as 2u into t is equal to 2 into 50, that is 100 plus t square. 100 plus t square. Therefore, t is equal to 100. Here we can use, that is the formula x is equal to minus b plus or minus b square minus 4ac divided by 2a. So that formula I can use and I can calculate the value of t as, it is becoming 2u plus or minus under root of 4u square minus 400 whole divided by 2. So therefore, to get the roots, we can assume that 4u square is much greater than or equal to 400. Therefore, we will get u is equal to 10 meter per second. We will get u is equal to 10 meter per second is the option. Option C is the correct option here. See, once again, I'll repeat what all we did here. Here we have calculated the initial velocity of the boy. To calculate the initial velocity of the boy, we require first time. To calculate time, we have used the formula x is equal to minus b plus or minus under root of 4ac minus divided by 2a. So that formula we can use, and we can use this formula and simplify the initial velocity. The initial velocity is found to be 10 meter per second. That is option C is the correct option here. Option C is the correct option. Then next, let us continue with the next question. A car moving with a speed of 50 km per hour can be stopped by brakes after at least 6 minutes. After at least 6 minutes, if the same car is moving at a speed of 100 km per hour, the minimum stopping distance is. See here, students, you have a car moving with a speed of 50 km per hour, which can be stopped. Means initial velocity is 50 km per hour, which can be stopped means the final velocity is 0 at least 6 meter. Means after traveling a distance of 6 meter. If the same car is moving at the speed of 100 km per hour, the minimum stopping distance. Here, when it is moving with 50 km per hour, it will travel a distance of 6 meter before it stops. When it is moving with 100 km per hour, before stopping, how much distance it covers, that we need to calculate. So here the solution is that is it is v square is equal to u square minus 2as. So final velocity is 0 as the vehicle is going to stop. This is equal to u square minus 2a into s, that is equal to 2as is equal to u square. Therefore, the distance traveled s is equal to what we can write? U square divided by 2a. So from this equation, can we say that s is proportional to u square? Right, students? S is equal to u square by 2a. Therefore, we can write it as s is proportional to u square. Therefore, s2 divided by s1 is equal to, we can write it as u2 divided by u1 whole square. As we know s2, s1 value, sorry, s2 we need to calculate, s1 value we know. I will just write it. That is s2 divided by s1 is 6 is equal to u2 is 100, u1 is 50. Right, so 0, 0 will get cancelled. 5 ones are 5 twos are. So 2 square, it is 4. Okay, as it is the square. 5 ones are 5 twos, it is 2 square is 4. Therefore, s2 by 6 is equal to 4. Therefore, s2 is equal to 4 into 6. 4 into 6 is how much? It is 24 meter. It is 24 meter. Therefore, the correct option is option D. Option D is the correct option here. Okay. Option D, 24 meter is the correct option. Next, let us continue with the next question. If a body having initial velocity 0, so I'll write what all quantity it is given. That is a body having initial velocity 0, moving with a uniform acceleration of 8 meter per second square. The distance traveled it in fifth second is the distance traveled in fifth second is we need to calculate here. Okay, means t is equal to 5. We need to calculate the distance traveled. Therefore, the distance traveled is equal to ut plus half at square. That is equal to ut. U into t. U is initial velocity is 0. Therefore, it is 0 plus 1 by 2. A is 8 into t square is 5. It is 5 square. That is equal to 2 1s are 2 4s are. Okay. Then 5 square is 25. 25 into 4. So here the distance traveled, once again, that is the distance traveled in the fifth second they have asked, right? So we cannot use this formula because the distance traveled in the fifth second they have given. It is not given that it is 5 seconds. It is given that it is in the fifth seconds. Therefore, here we need to use the formula that is Sn is equal to, we need to use Sn is equal to u plus a by 2 into 2n minus 1. U plus a by 2 into tn minus 1. That is equal to u value is initial velocity is 0 plus a by 2. A is 8 by 2 into bracket 2 into fifth, that is 5 minus 1. This is equal to 8 by 2 is 4 into bracket 10 minus 1. So 10 minus 1 is 9. 9 into 4, 36 meters. So the distance traveled is how much? It is 36 meters. 36 meter is the answer. That is option A is the correct option here. So here students, they have not given time is 5 seconds. It is given that the time is fifth second, which means that it is the nth term. So we need to use the fourth equation of motion, that is Sn is equal to u plus a by 2 into bracket 2n minus 1 into bracket 2n minus 1 is the formula which we need to use here, right? Then let us continue the next question. A body sliding on a smooth inclined plane requires 4 seconds to reach the bottom starting from rest at the top. So a body is sliding on a smooth inclined plane. It is sliding on a smooth inclined plane. It requires 4 seconds. It requires how many seconds? 4 seconds here to reach the bottom starting from rest at the top. How much time does it take to cover 1/4 distance starting from rest at the top? See here, solution how we can do. We have S is equal to, starting from the rest it is, therefore instead of taking S is equal to ut plus half at square, I'll take it as 1 by 2 at square. I'll take it as 1 by 2 at square. Can I simplify this equation as t is equal to? So t is equal to, I can write it as root of S. So here t is equal to, it is becoming root of S. Why? Because that is, I am just taking the relation between S and T here. Okay. Because the time and 1/4 distance they have given, therefore I am taking it as S and T relation. Now, can I take the ratio like this? T2 divided by T1 root of S2 divided by S1. This is equal to, see here, how much time does it take to cover 1/4 distance starting from rest at the top. Therefore, this can be written as under root of, it is 1/4 means S by 4 divided by S. So S will get cancelled. You will get 1 by 4. 1 by 4 root is nothing but what? It is 1 by 2. Therefore, T2 by T1 is equal to 1 by 2. That is nothing but T2 is equal to 4 divided by 2. So 4 divided by 2 is how much? It is 2 seconds. It is 2 seconds is the answer. Therefore, the correct option is option B is the correct option. Option B is the correct option here. Is it clear? So here the question is what? That is a body is sliding on a smooth inclined plane, it requires 4 seconds they have given. Means T1 value they have given to reach the bottom sliding from rest at the top. Initial velocity is given. So when it is sliding from the top, it will take 4 seconds to reach the bottom. How much time does it take to cover 1/4 the distance? Means here the figure, you can assume something like this. This is one inclined plane you can take. So on this body is sliding here, you can assume one body which is sliding over here. So it will reach this distance in 4 seconds. 1/4 the distance means up to this mark. How much time does it take? It is taking 2 seconds. Okay. So you can use the relation of time and distance. Okay, students. So today we have covered numericals based on equation of motion. So maximum we have discussed the questions on equation of motion. So in the next class also, let us continue with the same problems, with the same problem in the sense same equations, different problems we will discuss. Okay, so go through the synopsis and go through all the MCQs once again. Thank you.